This is the screencast for section 3.1, example 4, transforming exponential functions. Optimus Prime. Describe how to transform the graph of f of x equals 2 to the x into the graph of the given function. Sketch the graphs by hand and support your answer with a grapher. Of course we will. All right, so part A, that is an exponential function. So here's your base of 2 to the x minus 1. Well, I know that, let's see, the original function is 2 to the x because the original problem says that. So the minus 1 is in the exponent with the x, so that is a horizontal change. That is a horizontal shift. Now since I'm subtracting, that's going to move it right 1. Horizontal shift right 1. Okay, so the basic function y equals 2 to the x, if I plug in 0 for x, we'll cross the y-intercept at, or cross the y-axis at 1. So instead of 0, 1, now that graph is going to be at 1, 1, because it got moved over to the right. Now when I plug in 0 for x, 0, let's see, minus 1 is negative 1, 2 to the negative 1 is 1/2. And that makes sense. So there is my graph that has been horizontally shifted right 1. So I know 2 points on this, 1, 1, and 0, 1/2. B, let's see, the negative sign is in with, again, with the horizontals by the x-coordinate, or the input variable. And so that is going to be a horizontal flip over the y-axis. Which means if my original graph, which I should probably just draw up here, that's 0, 1. So there's my original graph. Now that's going to get flipped over the y-axis. So 0, 1 is still going to stay there, but now instead of growing up to the right, it's going to decay. Ooh, that was bad. It's going to decay down to the right. So that point 0, 1 is still there. It's just the rate of growth decays off to the right instead of grows. Part C. Now that change is not with the input variable, that is in front of the function, so that is a vertical stretch by 3. So the new sketch, instead of having the point 0, 1, is going to have the point 0, 3. The y-coordinate is going to get 3 times as tall. So, still going to level out the same way, it just got kind of stretched. I'm a really bad drawer today. There we go. So that would be 0, 3. Now, of course, I'm going to check these all on my calculator. So after checking on my calculator, I can see that each of my graphs line up. On this first one, I did check and I got the point 0, 1/2 as I accurately predicted, and then 1, 1 also looks like it's on there. This one, you can see that it crosses through the x-axis still at 0, or the y-axis still at 0, 1, and then decays to the right. This one says that it crosses through 0, 3, and my graph does show that. Now here, take a look at B. Remember B has 2 to the negative x, which is also 1/2 x. Remember, I've been using the word decay here. Look at that. That is exponential decay. So the graph will actually decay off to the right instead of grow off to the right. Be careful. Decay does not mean decrease. Decay does not mean decrease. We will talk more about that in a couple examples. The now try problem is example 15. Describe how to transform the function, the graph of f into the graph of g. Sketch the graphs by hand, and of course support your answer with the grapher. So if f of x equals 2 to the x, the same function we were dealing with in the example, g of x is 2 to the x minus 3. So since the minus 3 is affecting the input variable, that is going to be a horizontal shift right 3. Which means instead of the function crossing through 0, 1, instead of 0, comma 1, it's going to be 1, 2, 3, comma 1. It's going to look the same, just got shifted to the right 3. Which means if I plug in 0, 0 minus 3 is negative 3, so the 2 to the negative 3 power is 1/8. So this should be 0, comma 1/8. So I will check those when I graph them on my calculator. So I was right. The point 0, comma 1 got moved right 3 to 3, comma 1. So we added 3 to the x-coordinate. There it is. As well as when I plug in 0, the y-intercept is 1/8. 0.125, 1/8.